So in this video we are going to discuss about the concept of flooding and SPIN protocol. So when you consider this flooding, so it is basically a it is used for data gathering and data dissemination in wireless sensor networks. So it is used for path discovery and information dissemination. It can be used in both wired and wireless ad hoc networks. So it uses a reactive approach where each node, after receiving a data or control packet, just disseminates or sends that packet to all its neighbors. So by this way what happens is a particular packet, a data packet or control packet, will be flooded across all the nodes in the network, and whenever there is a change in the network topology also, the packet gets transmitted via the new routes. So it is the simplest way to transmit the data packets across all the nodes in the network. So even though flooding is a basic method for transferring the data packets across all the nodes in the network, it has various disadvantages. So this diagram depicts the concept of flooding. So a data packet from A, it is moved to B, and the data packet that is received from A to B is again disseminated to its neighbors. So C, E and D and F. So these nodes will get the data packets of A via this B. And when you consider this C, it gets the data packet from A via this B as well as from via this E. So by this way what happens is duplicate copies. So each and every node will get duplicate copies of the same data packet or control packet. And to prevent such duplicate packets, one thing is hop count can be used, and the other one is time to live field. So hop count, it just maintains a minimum amount of nodes that can be traveled by a packet, and time to live field, so it just reduces the duration of time period in which the data packet can be circulated around the network. And when you consider this flooding, it has several deficiencies or drawbacks. The first one is traffic implosion. So by this traffic implosion, duplicate copies of the same data or control packet can be received by a node. So when you consider here the same logic, so the packet has been traveled from A and is disseminated to its immediate neighbors B and C. So on receiving that data packet, this B disseminates it to its immediate neighbor. So D will receive a copy of data packet of A via this B, similarly via this C. So the data packet from A is getting duplicated in this node D, since it is getting two copies of the same packet from B and C, that is traffic implosion. And the second drawback is overlap problem. So when this is also getting the duplicate copies. So overlapping occurs when two nodes covering the same region sends packets containing similar information to the same node. That is when you consider this R, it is it is in the region of Q as well as in the region of S. So the data packet transmitted by this R will be received by A, that is in this region Q, and B in this region S. So these are overlapped. So this is the overlapped region, right? So when the nodes in this region R transmit a packet that will be received by A and B, and in turn on getting this packets, A and B will be disseminating that packet to C. By this way your node C will be receiving duplicate copies. And the third one is resource blindness. So obviously when you consider your WSN, it is a resource constrained network, right? So energy, it has to use the energy to the minimum extent, right? So when flooding is used in order to disseminate the packet, your resources are utilized to the maximum, and it is an unnecessary usage of resources. That is resource blindness. So these are some of the drawbacks in the traditional data dissemination protocol called flooding. And to overcome this, gossiping is used. So gossiping is a simple forwarding rule and does not require costly topology maintenance. Contrary to flooding, where a data packet is broadcast to all its neighbors, gossiping requires that each node sends the incoming packet to a randomly selected neighbor. So instead of flooding the data packet to all its immediate neighbors, it randomly selects some neighbors and sends the packet. And once the data packet is received by that randomly selected neighbor, again it will select from its neighbors, it will be selecting one random neighbor, it will be transmitting. That is, so this process, it gets continued until all the nodes in network receives a copy of that particular data packet. So gossiping is an alternative approach to flooding. And the next topic is negotiation based routing protocol. Sensor protocols for information via negotiation. So this is SPIN. It is a negotiation based protocol. It is also a data centric and time driven flooding protocol. and it addresses the drawbacks of the traditional flooding protocol. So it addresses the problems of implosion and overlap. So it just negotiates with our neighbors before they transmit data, allowing them to avoid unnecessary communication. So it just negotiates with the neighbor. Only if the neighbor needs the data packet, it is going to forward the data packet. And to address the problem of resource blindness, before starting that data communication, a resource manager will be there in all the nodes, and only if there is sufficient resource, the data communication will take place. So when you consider the SPIN protocol, there are various types. The first one is SPIN PP. So it is point-to-point protocol, where two nodes can communicate exclusively with each other without interference from other nodes. So in this protocol, it uses a three-way handshake protocol, advertisement, a request, and then data. So when a new data arrives to a particular node, it just advertises this event via an advertisement message to its neighbors. Upon receiving this advertisement message, a node checks whether it has already received that particular data packet, and only if it does not receive the data packet already, it just responds with a request message. Once the request message is received by the sender node, it just sends the data only to that requested node. So that is described by a diagram, where this node A, after getting one particular data packet, just advertises that event to all its immediate neighbors. And each and every node B, C, D, and E, it checks its history, and it finds out whether it has already received the data packet. So your B and D, it is sending a request message. So it means that C and E would have already received a copy of that particular data packet. So it is not sending a request message. The node B and node D is they are sending a request message. So upon getting that request message, this node A is advertising, that is, it is transmitting the data packet only to those nodes from which it received the request message. So it is sending the data only to node B and node D. So the key advantage of this particular protocol is its simplicity. And the next one is EC. A variation of your SPIN PP protocol is SPIN EC, energy conservation. So energy is the main constraint with all the nodes in WSN. So this particular protocol, before initiating that three-way handshake protocol, it just gets assurance whether the nodes have sufficient energy to participate in this three-way handshake protocol. So once the energy of a node approaches a specific low energy threshold, it becomes more selective in its participation in the protocol. That is, a node should only participate in a three-way handshake if it believes that it can complete all stages of the protocol without falling below the energy threshold. So that is what I am trying to explain. So that is, in order to participate in this three-way handshake protocol, the node should have sufficient energy. So if in case the energy is below a threshold value, it is not possible for the node to complete that three-way handshake protocol. So your SPIN EC is just a variation of PP protocol. Before initiating that three-way handshake protocol, it just confirms whether there is sufficient energy among the nodes, two nodes which they are going to communicate. And the BC. So it is a broadcast transmission, where once a data is received, that particular data will be broadcasted. So that is, all the nodes within that transmission area in this range, radio range, will receive the transmitted data. So your SPIN BC, again, it uses the three-way handshake protocol of advertisement, request, and data, similar to your SPIN PP. So all messages are directed to be broadcast message, right? So that is, all nodes within a sender's transmission rate will receive a copy of the data. Upon receiving an advertisement message, a node checks whether it wishes. So that is, all the nodes within its radio range will receive that advertisement message, right? But it is sufficient when one node has given a request message. So each and every node will wait for a particular period of time, and it checks whether the request message has been sent by some other node. So if no other nodes have sent the request message, this node will send the request message. Anyway, your sender node will be receiving a request message from any one node. So once it receives a request message, obviously it is going to broadcast the data, and obviously the nodes within that range will get the broadcasted data. And finally, SPIN RL. So this SPIN RL, it is again a variant of SPIN BC protocol, a reliable version that addresses the packet loss and asymmetric communication. So first, each node keeps track of overhead request messages, and if it does not receive a corresponding data message in a certain time interval, it assumes that either the request message or the data message not arrive. So your SPIN BC protocol, what it will do, So it has any one node will send a request message. On getting that request message, the initiated node has to send the data packet. So when that data packet is not received within a particular time period, this spin RL, so it's a reliable version, it has to take care of that packet loss. So in such cases, the node re-requests the data by broadcasting and request message, right? So that is, it takes care of this packet loss and asymmetric communications also. Right, so this is about your spin protocol, where it has different variations like PP, AEC, BC and RI.